Hello students. So in this video we'll be looking at gravitation PYQ from April 2023 attempt, right? So let us start. So our first question says, consider a planet in some solar system which has a mass double the mass of Earth. Okay, mass of planet is given 2 times mass of Earth and density equals to average density of the Earth. Density of planet is equals to density of the Earth. Fine. An object weighing W on the Earth will weigh. Okay. On the planet, they are asking us what will be the weight of object whose weight on Earth is W. Fine. Why weight will change? Because G will change. What is our weight? Weight is basically M into G. Because on another planet, your G value will change. Therefore, your weight will also change. Now, beta, over here, they have given us in terms of density, radius, they have not given any information about radius. So, what we will do is, our G value in terms of density, what do we write it? G, small g, in terms, general formula is G M by R square. This is our relation for G. And in terms of density, we can write it as 4 by 3 pi rho gr. Okay, this is what is our relation in terms of density. We get it from this only. Now over here, if you notice carefully, density for both of them is same, but radius. Let us look at radius. How can we relate the radius of Earth and radius of the planet? Rp and Re. Radius of Earth. How to do it? Let us see. Density is given equal. So density of planet, what can I write it? Mass of planet by volume of the planet. That will be your 4 by 3 pi Rp cube. This is equals to density of Earth, mass of Earth by 4 by 3 pi Re cube. Mass of planet, how much they have given? 2 times. So I am putting over here 2 times mass of Earth. Let's see, simplify it. 4 by 3 pi, 4 by 3 pi cancels out. So we get over here 2 times radius of Earth cube is equals to radius of planet cube. So from this we get over here radius of planet is equals to 2 power 1 by 3 into radius of Earth. This is our relation between radius of planet and radius of Earth. We got it. Now let us see what this is our G on Earth. Let's say G on Earth, radius on Earth, radius of Earth, and our density is same for both of them. Fine. So now what can I write? G on planet. G on planet will be again 4 by 3 pi rho g r of planet. R of planet, how much we got it? 2 power 1 by 3 Re into 2 power 1 by 3. Now this is what? This is nothing but G on Earth. So Gp is equals to 2 power 1 by 3 G on Earth. From this you can identify this is M, this is M. That implies weight on planet will be 2 power 1 by 3 weight on Earth, which is W given to us, right? So this is our answer. Option, check the option, which option we have? Option D. Option D is our correct answer, 2 power 1 by 3 into W, right? Let's look at the next question. Yeah. So our next question is a certain region question. So let us see. Let's look at the statement. Statement 1 says, atmosphere, Earth has atmosphere, whereas Moon does not have any atmosphere. This is a factual information, right? We should know. This is a factual information. Earth has a layer of atmosphere, whereas Moon does not have any atmosphere layer over it, right? Fine, this is correct statement. That means reason R says the escape velocity on Moon is very small as compared to that on Earth. Yes, this statement is right, because beta escape velocity, what do we write escape velocity? It is root over 2 gm by r. And the mass of Earth is very large as compared to mass of Moon. And factual information, if we know, escape velocity on Earth is how much? 11.2 kilometer per second. Now this is very, very large for the gas molecules. The gas molecules which are present in the atmosphere, this escape velocity is very large for them, and they are unable to escape from the Earth's surface. Whereas in case of Moon, your mass of Moon is less. That's why escape velocity is also less. Escape velocity is less, therefore the gas molecules will escape from the surface, right? So that means statement 2 is correct, statement 1 is correct, statement 2 is correct, and statement 2 is the correct reasoning for the statement 1. So let us look at our options. Option number 4. Now basically A and R are correct, and it is the right explanation, right? Let's look at our next question. Yeah, next question is, the weight of a body on the surface of Earth is 100 Newton. Fine, on the surface weight is 100 Newton. The gravitational force on it when taken at a height from the surface of earth equal to 1/4 of the radius of earth is. Gravitational force is basically your weight only, and gravitational force is nothing but weight only, mg. So when it is taken to a height of 1/4 of the radius of earth, r/4, over here what is the weight or what is the gravitational force? Let us call it as w at h, w at h, or force, that is what it is. So how do we calculate? Why gravitational force will change? Because your g value will change. So let us calculate g value at 1/4 of the height. So this is your h. What is our g value? G value at height h is g times r by r plus h whole square. So gh is equals to g times r by r plus r by 4, because they have taken it 1/4 of the radius of earth. So when we simplify it, we get g times 4r by 5r whole square. Okay. So gh is equals to 16g by 25. Fine, well and good. Now let us see. So at height h, what will be your force? Force will be m into gh, which is m into gh is 16 by 25 g. Fine, which I can write as 16 by 25 mg. And how much is our mg value given on the surface? It is 100 Newton. Force on the surface is your weight on the surface. So we can write it, F is equals to 16 by 25 into 100. So we get over here 4 times 16, 4 is 64. 64 Newton. 64 Newton is our right answer. Option number 2. Option number 2 is our correct answer, right? Let's look at the next question. Yeah. Next question, it's a theoretical based question, right? Over here our knowledge of satellite motion and your Kepler's law will be used. Let us look at all the statement one by one. They are asking us choose the incorrect. I think it's somewhat not visible to you guys. I'll read it. The first line is choose the incorrect statement from the following. 4 statements are given to us one by one. We'll take a look at each one of them. First statement says the speed of satellite in a given circular orbit remains constant. The speed of satellite in a given circular orbit. Fine. Satellite. So Earth, satellite moves around Earth. What is the orbital speed? Orbital speed is given as root over gm by r. This is mass of Earth. This is orbital radius, right? So yes, in a given circular orbit, it is remain constant only. Speed is given, so speed remains constant. Velocity changes, but speed remains constant. That means this is the correct statement. This is right. So fine, they are asking us incorrect, huh? So this one is correct, fine. Second statement says, for a planet revolving around the sun in an elliptical orbit, the total energy of planet remains same. Okay, planet, sun is at our foci. Sun is at our foci. This is planet moving around it. Total energy remains constant, right? Kinetic energy and potential energy, they will be changing, but your total energy will remain constant, right? So this is again your second statement, correct? This is from Kepler's law of actual information. Third is, when a body falls towards Earth, the displacement of Earth towards the body is negligible. Yes, this is very much right. We experience also in our day-to-day life. If any object is falling towards Earth with a force, it is also applying a force. This, if it applies a force F on the body, if Earth is applying force F on the body, this body is also applying same force F on the Earth. But because, as we see, acceleration is force by mass, mass of Earth is very, very large. Therefore, this acceleration is negligible. It does not affect your Earth. That's why its displacement is 0. Fine. So this statement again is correct. So that means option left is fourth only, but let us check it. What option we have? The linear speed of planet revolving around the sun remains constant. Linear speed of planet revolving around the sun remains constant. So yes, this is an incorrect statement. This is an incorrect statement. Reason being, when planet is revolving around the sun, your speed will change. Speed is maximum when it is over here nearest to the sun, and it is minimum when it is farthest from the sun. Speed will change. In an elliptical orbit, speed does not remain same. Speed will change, and which is the quantity that remains same? It is your angular momentum. Angular momentum remains same, but speed will continuously change. Over here you will have more speed, and here you have V minimum, right? That means this is an incorrect statement. Fourth is an incorrect statement, and that will be our answer also, because they are asking us incorrect, right? So fourth is the right answer for us. Let us look at the next question. I have drawn over here. Oh, it's not visible to you guys. Sorry. It's basically, I'll show you. In the flow, I didn't see it. So this is there. Basically, I was explaining that on Earth, acceleration will be your acceleration of the earth will be F by me, but mass of earth is very, very large. That's why acceleration is negligible. So it does not move, displacement is 0. That is what I was showing over here, right? Let's look at the next question. Yeah. Next question says the weight of a body on the earth is 400 Newton. Weight of body on the earth's surface is 400 Newton. Fine. Then the weight of body when taken to a depth half of the radius of earth. That means somewhere over here d value is how much? Half of the radius of earth. And depth is r by 2. Okay, weight they are asking at this. Basically g will change. Question is from variation of g. So what do we know? What will we write it? Weight at depth d, it will be written as m into gd. So once we get our acceleration due to gravity at depth d, we will get our weight also. Let us calculate. What is our formula? Relation says gd is g times 1 minus d by r. Let's take a look. G times 1 minus d value is r by 2. So r by 2 into r cancel out. 1 minus 1 by 2, that implies it is g by 2. So at depth d, that is r by 2, your g value is becoming g by 2 times. So what can I write it over here? M into g by 2, and this value is given to us as 400. So weight will be 400 by 2, which is your 200 Newton. 200 Newton is our right answer, right? Let's look at the next question. Yeah. So our next question is, the orbital angular momentum of a satellite is L when it is revolving in a circular orbit at a height h from the Earth's surface. Fine. Let us draw the situation. Let's say Earth, it is revolving at a height of h. It is revolving at a height of h, and so over here satellite angular momentum is given as L. Let us write down at this point how will we define it. So L will be what, beta? M into V into R. MVR, right? Angular momentum will be given as MVR. Now V is the orbital speed and R is the orbital radius, which I can also write as r plus h. I hope this is okay. Orbital radius is the distance from the center. So r plus h. This is what we got it. Now what is our orbital speed? Orbital speed is given as root over g mass of earth by radius. Fine. Next what it says is, if the distance of satellite from the earth center is increased by 8 times. Now please be careful with this over here, the statement, read it carefully. If the distance of satellite from the earth center is increased by 8 times, it is increased by 8 times, that implies your orbital radius is increasing by 8 times. That means how much it is becoming? 9r. If initially it was r, they are increasing by 8 times. That means it is your r plus 8r. That is orbital radius now is your r dash is 9r. Fine. So then the new angular momentum will be fine. Well and good. So at this point, when they have increased by 8r and your orbital radius become 9r, let us write down L dash. New angular momentum I am terming as L dash. So L dash will be mv dash into r dash, because speed will also change. Speed depends on the orbital radius. So speed also changes. So mv dash r dash. R dash, we know it, it is 9r, no issues, directly we can write it. But V dash, let us calculate your orbital speed in terms of r. So what can we write it? V dash value is root over gm by r dash. Gm by r dash. How much is our r dash? 9r. So root over gm by 9r, which is 1 by 3 times root over gm by r. What do we get it? Orbital speed is 1 by 3 times v. That means finally orbital speed is 1 by 3 times v. Now I'll use this relation over here. See over here, L dash is equals to m into v dash, which is 1 by 3 v into r dash. R dash value is 9r. So 3 times, which is it visible there? Visible. So over here L dash can be written as 3 times mvr. What is our mvr? Mvr is the initial angular momentum. So L dash becomes 3L. Okay? I hope this is clear. Answer is 3L. Option number 4 according to my options, right? Fourth will be the option 3L. Let's look at the next question. Yeah. Our next question is acceleration due to gravity at height h above the earth if h is less than r is given by. Acceleration due to gravity, that is g, at h less than r. Now beta, there are two relations. This is very specific, very clear cut. There are two relations for g variation. At height h we write as g by g times r by r plus h whole square. And but if this is the condition given to you when h is very less than r, then g is written as g times 1 minus 2h by r. And this comes by binomial expansion. By from this relation only this one comes. For smaller values of h, this relation is given. So I hope this is clear. Direct formula based question. It is your first option. First option will be your correct answer. Right? Let's look at the next question. Yeah. So our next question is, it says, two satellites of masses m and 3m revolve around the earth in circular orbits of radii r and 3r. Fine. Earth, two satellites, circular orbits r and 3r. This is what is given to us. Two satellites, mass is given to us m and 3m. Okay. They are asking us the ratio of orbital speed of satellites is ratio of orbital speed. Now beta, what is the relation for orbital speed of satellite? Orbital speed is basically given as gm by r. Now this m is mass of the planet, not the mass of satellite. This m is mass of the planet, which for both of them is earth only, so it is same. So basically we can write down orbital velocity of first by orbital velocity of second. It is inversely proportional to your root r. Okay, so what can I write it? This will become basically your r2 by r1. R2 value is 3r and r1 value is r. So our answer will come root 3 is to 1. Root 3 is to 1, option is 3. Option 3 is the correct answer, right? Over here in this formula, this m is the mass of the planet, not mass of satellite. Right, let's look at next question. Our next question says, assuming the earth to be a sphere of uniform mass density, the weight of body at the depth d equals to r by 2 from the surface of earth if its weight on the surface of earth is 200 Newton. Okay, so on the surface weight, which is mg, which is equals to 200 Newton given to us. They are asking us weight at a depth d, which is equals to r by 2. Right, this is kind of same question what we did, question number 6 that we did in this video. These are basically questions from two different shifts, two different shifts, same year, this appreciation only, April attempt only, but two different shifts it is. So same question, kind of values are changed. Let us see. So what can I write it? W dash will be, or W at depth d will be m into gd. Let us calculate. G at depth d is given as g times 1 minus d by r. Fine. G times 1 minus d. D value is how much? R by 2. So r by 2 by r cancels out. We will get g 1 minus 1 by 2, that is your g by 2. So from this you can see it will come out to be your mg by 2, which is 200 by 2, that is 100 Newton. 100 Newton is our answer, right? Yeah. Next is a theoretical question. Let's see. Statement 1 says rotation of earth shows effect on the value of acceleration due to gravity. Yes, this is a correct statement. Due to rotation, there is an effect on g value. What is our relation? We write g effective is equals to g minus r omega square cos square lambda, right? What is lambda over here? Lambda is this angle, latitude angle lambda. Now this is what it is. Their g value changes. That means your statement 1 is correct. What does statement 2 says? The effect of rotation due to rotation of earth on the value of g at the equator is minimum, and at the pole it is maximum. Let us see. At the equator lambda value will be 0, cos 0 is 1, and therefore at equator your value will be means it will be minimum and it will have maximum effect. It will have maximum effect at equator At equator, if I have to write, G effective will be G minus R omega square. Whereas at pole, if I have to write it, it will be G effective value will be at pole G minus lambda. Lambda is 90, so over there cos 90 0. That implies it becomes G minus 0, so that is G only. So at the equator, it has maximum effect. In the statement, what they have given? Value of G at the equator is the effect of rotation on the value of G at the equator is minimum. No, at the equator it has maximum effect. That means statement 2 is wrong. Statement 1 is right and statement 2 is wrong. It has maximum effect on equator value and minimum effect on the pole value, right? Let's look at the next question. Yeah. So our next question is, the time period of a satellite revolving around the Earth's surface at a height equal to r will be, okay, 4 options are given. In terms of r they are asking. So this is what it is. Earth, it is revolving at a height which is given equals to r. Fine. The time period of satellite, some information is given to you. Take G value as pi square and r is your radius of Earth. Fine. Now, time period, they are asking us what is the relation for time period of satellite. We write time period as 2 pi by root gm into r power 3 by 2. And now this is orbital radius. This is our orbital radius. I hope this is okay with you, right? So let us simplify this result. They are asking us answer t in terms of radius r. So let's write it 2 pi by root gm. This value will be your how much? Orbital radius. If it is at a height of r, that means orbital radius is distance measured from the center. So from center it will be r plus r, that is your 2r. So 2r whole power 3 by 2. Now what I'll do is, to simplify this calculation, I'll square it on the both sides so that we can deal with it properly. T square will be 4 pi square, root gm will be gm, and this will be 2r whole power 3 by 2. This square will become your 2r cube. ठीक है बेटा? So t square is, it's visible this side, t square is equals to 4 pi square by gm. Now see over here, 2 cube is 8, and what I will do is, this r cube is there na, r cube we will write it as r square into r. R cube will write it as r square into r. Why I have done this is because this term, if you see carefully over here, gm by r square, this r cube, 2r whole cube, that is 8r cube. 8r cube I have written as 8r square into r. Why we have done it is because gm by r square. What is our gm by r square? Gm by r square is nothing but small g. Okay, that means this I can replace it. We will get t square is equals to 4 pi square. This can be replaced by small g into 8r, right? In the question what they have given us, that small g value can be taken as your, or small g can be taken pi square or pi square as g. So this implies it cancels out. So we are left with t square is equals to 32r. T square is 32r. Directly you got the answer now. So t value will be what? Root 32r. T is root 32r, right? Option number 3 according to the options, right? Option number 3 will be the correct answer. Let's look at the next question. Yeah. Question says, the radii of two planets A and B are r and 4r. For planet A, radius is r. For planet B, radius is 4r. And their densities are rho and rho by 3. Densities are rho and rho by 3. Fine. The ratio of acceleration due to gravity at the surface, at their surface, Ga by Gb, Ga is to Gb, Ga is to Gb. This is what they are asking us. What information is given? Radius is given, density is given. Now G value, generally we write it as what? G value is written as G capital M by R square. But in terms of density, what can we write it? In terms of density, we write it as 4 by 3 pi G rho R. This is what is given. Simple. We know radius and density. Let's take the ratio. Ga by Gb. if we'll take the ratio 4 by 3 pi, G will be directly cancelling out. So we only have rho A RA by rho B RB. Rho A by rho B will be your rho by 3 into RA by RB, that is your R by 4R. Cancels out, 3:4. 3:4 is our right answer, right? This is what was written. Fine. Yeah. Next question is, it's a good question, see carefully. A spaceship of mass 2 into 10 power 4 kg, okay, 2 into 10 power 4 kg, is launched into a circular orbit close to the Earth's surface. Fine. So this is your, the satellite is very close to the Earth's surface, very close to the Earth's surface as mentioned in the question. That means its orbital radius will be how much? R only. And by mentioning this, that it is very close to the surface of Earth, that implies that its orbital radius will be taken as R. We take it like this, R plus H, and this is very close. That means your R value is radius of Earth only. Fine, orbital radius is radius of Earth. The additional velocity to be imparted to the spaceship in order to overcome the gravitational pull will be, this is a definition of escape velocity. This is the definition of escape velocity, and also they are asking us the additional velocity that we should provide. Now what happens is, what is escape velocity? Escape velocity is root over 2gm by r. This is what it is. Now over here the additional velocity that we should provide it is root 2 minus 1 into v naught. For a satellite, I am writing the direct relation over here. I will show you how it comes. So the additional velocity that we should provide, v dash, I am writing this, the additional, the extra velocity. What will happen? The satellite will be revolving around the Earth with a speed of v naught. How much is our v naught orbital speed? We write it as root over gm by r. Okay, beta, this is what is our orbital speed. Now this is our orbital speed, and if we want to escape it, escape velocity is basically given as this. Escape velocity is basically given this. Now they are asking us what should be the additional, extra, how much it should be given. So as you can see over here, extra if you have to give, if we look at the change 1 minus 2, if you do 1 minus 2, it will come out to be your, this 1 minus 2, if you do it, it will come out root 2 minus 1 into root over gm by r, okay, which is nothing but your root 2 minus 1 into v naught. Please keep this result in mind. It's an interesting result, that the extra speed that should be given for a satellite to escape in terms of what? In terms of its orbital speed. In terms of orbital speed is your root 2 minus 1 into v naught. This is how it comes out. Now over here, root 2 minus v naught, we have got this. So let's write down root 2 minus 1 into v naught. Orbital speed over here is root gm by r, which r over here? Orbital radius, and orbital radius is given to us as your capital R, because it is very near to the surface of Earth, so capital R. Now over here we can't put 6.67 into 10 power minus 11 and all that. Just this is your mass of Earth, this is not mass of the satellite, this is mass of Earth. So root 2 minus 1 into, we'll simplify this, gm can be written as what? Gr square. Gm can be written as small g r square, r cancels out, so we are left with v dash is equals to root 2 minus 1 root gr. G value is what? 10, and r value is 6400 kilometer, which I can write as 64 into 10 power 5. Okay, 64 into 10 power 5, that is in your meter. So this becomes 64 into 10 power 6 root 2 minus 1 into root over 64 into 10 power 6. Further, if I simplify this, I hope it's visible down. So root 2 minus 1 into root 64 is your 8 into 10 power 3. This answer will come in meter per second. This will come in meter per second. In the options, if you see, they have given to us in kilometer per second. That implies this can be written as, I can write as root 2 minus 1 8 times, that is kilometer per second. Okay, 8 into 10 power 3, so that we have written as kilometer per second. Fine, I hope this is clear. It was a good question. This the result, the additional speed that should be given. This is something that I calculated from here, right? You can remember this result. If it comes in the question, you can use it directly. Fine, let us look at it. Next question. Yeah, next question says two satellites A and B move around the Earth in same orbit. The mass of A is twice the mass of B. Okay, the quantity which is same for the two satellites is, beta, for satellites, four options are given: potential energy, total energy, kinetic energy, and speed. So we know total energy is basically minus G capital M small m by 2r, right? For them, which quantity is same? Okay, same orbit. That means orbital radius is same. Orbital radius is same, but your mass, this is mass of Earth, this is mass of satellite. Now, obviously, if mass of satellite is different, your total energy will be different. Similarly, potential energy will be different. Potential energy is basically given as minus G m small m by r. Again, kinetic energy is plus G capital M small m by 2r. So kinetic energy, potential energy, total energy will be different because it depends on the mass of the satellite. Whereas your speed, which is your orbital speed, is root over G capital M by r. Capital M over here is mass of the planet. That implies your orbital speed depends only on mass of planet and your orbital radius. Orbital radius is same. That's why your speed will be same. Option number 4. Option number 4 is the correct answer. Yeah. So our next question says the ratio of escape velocity of a planet to the escape velocity of Earth will be, the information that is given to you is mass of planet is 16 times mass of Earth, okay, and radius of planet is 4 times radius of Earth. They are asking us the ratio of the escape velocity. What is our escape velocity relation? Escape velocity is basically root over 2gm by r. Okay, this is what we have. That means 2g for both of them will be common only. Escape velocity is proportional to your what? Root over m by r. Escape velocity is proportional to root m by r. So for planet for Earth, escape velocity on Earth we can write as root over mass of planet by mass of Earth into radius of Earth by radius of planet. I hope this is okay. Let us take the ratios now. Mass of planet is 16m and into Re, which is Re. Mass of Earth m into radius of planet is 4Re. Re, cancels out. Root over 16 by 4, that implies this is your 4 times. So we get root 4:1, which is 2 by 1. 2 by 1 is our correct answer. Option number 2. Option number 2 is our correct answer, right? Yeah. So our question is, a planet having mass 9 ME, mass of planet is 9 ME, and radius 4 RE, radius of planet is 4 RE. Okay. ME and RE are the mass and radius of Earth respectively, has escape velocity in kilometer per second given by, 4 options are given to you: 67.2, 16.8, 33.6 and 11.2. Now see over here, what is our escape velocity result given for Earth? Escape velocity, we write it as root over 2g ME by RE, and we should know this, that the value of escape velocity on Earth is 11.2 kilometer per second. Fine, well and good. Now let us write down escape velocity for planet. How much it will be? It will come out to be, this is for planet, root over 2g MP by RP. And this is our escape velocity for any planet, we write it. Let's substitute the values. 2g MP, MP value is 9 ME by 4 RE. Okay. Now we have got root over 9 by 4. Root over 9 by 4 will be 3 by 2 root over 2g ME by RE. Right? Root over 2g ME by RE is nothing but your 11.2. So we get over here 3 by 2 into 11.2. When you will solve it, your answer will come out to be option number 2, which is 16.8 kilometer per second. And this will be 33.4 by 2. That implies 16.8 kilometer per second will be your answer. Right? Yeah. So our question is, two planets A and B of radii r and 1.5 r, radii r and 1.5 r, right? And their densities are rho and rho by 2 respectively. Rho by 2 respectively. The ratio of acceleration due to gravity at the surface of B is to 1. Okay, B is to 1. GB by GA. GB by GA. What can we write it in terms of density? In terms of density, we write it as 4 by 3 pi G rho of B r of B divided by 4 by 3 pi G rho of A r of A. Right? Rho B by rho A. Let us substitute it. Rho by 2 by rho into radius of B, that is your 3 by 2 r, and this one is r. When we simplify it, rho cancel, r cancel, we will get our answer as 3:4. 3:4. Which option it is? According to my option number 3, jumbling is there, please ignore that. 1, 3, 2, 4 is written. Now answer will be 3:4. Option will be 3:4. Third one, which is fine. Next is a theoretical question. Two statements are there. Let us look at it. For a planet, if the ratio of mass of planet to its radius increases, the escape velocity from the planet also increases. Escape velocity. Continuously, we have got 2-3 questions from escape velocity. Let us see. This is what it is given. Escape velocity is this. So if ratio of mass by radius will increase, obviously v will increase, right? It is correct only because escape velocity is directly proportional to your root over m by r. So ratio will increase. This will also increase. Statement 1 is correct. Statement 2. Statement 2 says escape velocity is independent of radius of planet. It depends on radius of planet. It depends. It is inversely proportional to root r, but it is dependent. Right? So it's not independent. That means statement 2 is wrong. Which option will you get it? Statement 1 is correct and statement 2 is wrong. Statement 2 is incorrect. According to the option, it should be option number 2. Right? Fine. Let's look at the next question. Yeah. So the last question of this video is: two identical particles, each of mass m, go round a circle of radius a under the action of their mutual gravitational force. Fine. Radius is a and two particles are there, each of mass m. Fine. Well and good. Okay. The angular speed of each particle will be, angular speed they are asking us, omega. How to calculate this? Why they will be moving in circular path? That means a force is required to move in circular path, which we call as centripetal force. How much we write it? We write it as, for any one particle, we'll write it as mass into acceleration centripetal, which is r omega square. R is given to us a, so I can write it ma omega square. This is our centripetal force. Who is providing the necessary centripetal force? The gravitational force is providing the necessary centripetal force. Gravitational force. How much is gravitational force? G m into m square by distance between them. Separation between them, it is 2a. So 2a square will be your 4a square. Second, right? Let us equate them. So we'll get our omega value. Ma omega square is equals to g m square by 4a square. Fine. M cancel out. Omega square value comes out. Gm by 4a cube. Right? Omega root over gm by 4a cube. This is our answer. Option number 3. It is option number 3 only. Yes, option number 3. Root over gm by 4a cube. This is it. So with this, we have completed our gravitation aptitude attempt, all the questions. Right? I hope you learned something from the video, and if you liked it, just press the like button and subscribe to our channel. Thank you very much. Bye bye.